Welcome to homework.
31.8. So we have a loop of inductors, capacitors, and resistors here with them in some sequence. And we want to show that regardless of uh, the sequence or anything of these, that it'll behave exactly the same as this simple LCR series circuit shown here in part B of the figure. So, and it tells us to consider the loop rule. So the total EMF has to equal the EMF from inductor 1 plus that from resistor 1 plus that from capacitor 1, and so on until we've exhausted however many indices we have here. So we can write this as a sum over J, say, of so the EMF from inductor J is going to be L sub J times di dt, because the current is the same in every element because they're all in series. And then that would be plus Q over C sub J plus I R sub J. So these are just the EMFs from each of the circuit elements. And so if we let L without a subscript be the sum of all of our L's, and similarly for C and R, then we know we can write this as three individual sums, and then the di dt, the q, and the I will come out of each of those sums, and we'll just be left with the sums over the component values. So we have like di dt times just the sum of the inductances plus q times the sum of 1 over the capacitances plus the current times the sum of the resistances. And so now we have L di dt plus Q over C plus IR. And then, of course, because this EMF loop is closed, it's all equal to 0. And we can see that this is the differential equation for the charge, because the I is the derivative of the charge, that this circuit obeys. And so now we've done what we set out to do.